Hello guys, welcome back to our channel. So today we are getting live. So we are solving some of the gate question. As gate 2025 is very much near, so we are solving some gate question. So please join as soon as possible. Then we can continue with the sessions. So we are waiting. So if anyone is being joined. So this is the limit question. So limit is very important as we can easily secure our 1 or 2 marks to the limit question. So as this is a very simple question, so we are applying the short tricks and we have to solve this question. So we are waiting to solve these questions 1 or 2 minutes. After that, I am solving the questions. So this is a very much a1 expression is given limit extending to 1 x cube minus 3x plus 2 upon x cube minus x square minus x plus 1 is equal to some value we have to find it out. So for this type of questions we have to putting the limit value to the expressions and get that if we get 0 by 0 form or not. If we get 0 by 0 form, then we can apply L'Hospital method for that. So if we putting the so we are putting the limit value to the expression. So if we putting the limit value to the expression, so we get so limit extending to 1 upon x cube minus 3x plus 2 upon x cube minus x square minus x plus 1. So if we put limit value x is equal to 1 to the equation, so we get 1 cube minus 3 into 1 plus 2 upon 1 cube minus 1 square minus 1 plus 1. So for this we get 1 minus 3 plus 2 upon 1 minus 1 minus 1 plus 1. So for 2 plus 1 is 3, 3 minus 3 is 0 upon 1 minus 1 cancel out, minus 1 plus 1 cancel out. So or 2 minus 2, so we get 0 by 0 form. So if we get 0 by 0 form, so um, we can then we can apply L'Hopital method for that. So L'Hopital method denotes that the derivative of first time derivative of the expressions or numerator or the denominator. So we write that putting the limit value to the expression, we get 0 by 0 form. So putting the limit value with the equations, we get 0 by 0 form. So we apply L'Hopital method. So we apply L'Hopital method or else hospital method. So if we apply L hospital method of this, so we get limit extending to 1. So first time of derivative of the expression. So x cube means 3x square, we get first time derivative minus 3x. So if we get 3 into 1 and some constant values, if we derivative of first time, so we get 0. And if the denominator, we get 3 into x square minus x square means 2 into x minus x something, so 1, and the constant value we get 0. So if we simplify this, so we get limit extending to 1, 3x square minus 3 upon 3x square minus 2x minus 1. So again we get some expressions. So now we are very much uh, dependent on this, focus on this expression now rather the main expression. So for this we can write, for this also we can put the limit value to the expression. So if we put the limit value to the expressions, then we get, if we put the limit value, so again we write, again putting the limit value to the expression. So again we put the limit value to the expression. So if we again put the limit value to the expression, so we get limit extending to 1. So 3 into 1 square minus 3 upon 3 into 1 square minus 2 into 1 minus 1. So we can write that 3 minus 3 upon 3 minus 2 minus 1 means we can get 0 by 0 form. So again we get 0 by 0 form. Again we get 0 by 0 form. Again we get 0 by 0 form. So again we apply L hospital method. Again we apply L hospital method for that. Again we apply L hospital method. So again we derivative the first time of derivative of this expression. So if we do so, so we get limit extending to 1, 3x square is first time derivative of, so we are now focusing on the on this expression, so not the main expressions, not the main this expression. So for these expressions we can get these expressions, the first time of derivative, then again we can do the same from the first time of derivative. So again we can emphasize of this or focus on this expression. So we are doing the first time of derivative, so we get 3 into 2x minus some constant value is 0 upon 3 into 2x minus 2 into 1 minus 0. So if we simplify this, we get 6x upon 6x minus 2. So if we get this, so then we can putting the limit value over here. So we get 6 into 1 upon 6 into 1 minus 2. So we get 6 upon 4 means 3 upon 2 means we have to get 1.5 is the answer of the question. So this is very easy question. So only we have to emphasize on the L hospitals method. So what does L hospitals method means and how to evaluate this using ill hospitals method. So this is the total solutions of this question. So for this type of if this type of expressions is given, then we have to do the putting the limit value to the expressions and check if anyway we get 0 by 0 forms or not. If we get 0 by 0 form, then we apply the else hospitals method. So applying L hospital methods means first times of derivative of numerator and denominator. If we get, then again in this case again we get the same type of expression. So we are checking again for the if L hospital possible or not. If not getting this type of expression, then we put the limit value and getting back the actual answer of this question. So I am waiting for 2 to 3 minutes to take a notes of these questions, and then we are going forward to do the next questions. So this type of limit question is easily come in the gate examinations, and we have to secure easily 1 or 2 marks in this type of question, solving this type of question. So now we move forward to the solving the second question. So the second question is also a limit question. So I am very much emphasize on the limit because this is easy to secure the question, to secure your marks in the gate examination. So this is the two limit questions. So I am waiting 1 or 2 minutes to try to solve this, and then we can do the solutions of these two questions. So the first question is came in the gate 2015 question. This is also a very much easy question. And the second question is came 2014. I am solving the first questions. So first question is giving as the limit extending to 0 e to the power x minus 1 upon sine x cube sin x, sorry. So this is the question. So for that we know the 2 or 3 formula: limit extending to 0 sin x upon x is equal to, we get 1 as the answer, and also limit x tending to 0 e to the power x minus 1 upon x is also giving the answer as a 1. Okay, so these two are basic formula we are also know. So for this we get x is equal to 0, so we are trying to replicate these expressions to, if we do so, so we are multiplying with 1 by x to the denominator and the denominator. So if we multiply with the 1 by x, so we get e to the power x minus 1 upon x upon sin x upon x. So for this, uh, for this 1 by x is cancelled out from the each one. So if we apply limit to the denominator and denominator both sides, so limit x tending to 0 e to the power x minus 1 upon x upon limit x tending to 0 sin x upon x. Okay, so for this we get, so this is and this is we can use the formula as limit extending to 0 uh, sin x upon x is equal to 1, and also limit extending to 0 e to the power x upon x is equal to also 1. So this expression is also getting the value as 1, this expression is also getting the value as 1, so we get 1 by 1, so 1 as the correct answer of the question. So this is a very much formula oriented question. So if we know these two formula 1 and 2, then we can easily solve these questions and easily secure 1 marks to the gate examination. So please write the solutions of these questions, and then we can proceed to the next questions. So now we move forward to the next question. So the next question is, so the next question is, the next question is this. So I am writing this in the below. So limit extending to 0 e to the power 5x minus 1 upon x to the power square 2. So this is the question. So for this also we have to check if any formula we have to derive from this. So if we multiply it with 1 by 5 to the denominator and denominator, then we can try to solve it out. Okay, so if we get multiplied, so if we multiply it with 1 by 5 to the denominator and denominator, okay, so 1 by 5 into e to the power 5x minus 1 means we have to, for this type of question, so the basic formula is e to the power x minus 1 upon x. So this value is same as the denominator value, so we have to also follow this is the 5x, so we have to just do this, the denominator value as a 5x, so that's I have to do the 1 by 5x, not 1 by 5, only 5 multiplied with 5 to the denominator and denominator. So 5 into same and 5 into x. So the denominator's e to the power's values and the denominator's values are same. So if we move out from the bracket, so we get limit extending to 0, 5 square into e to the power 5x minus 1 upon 5x whole square. So 5 square we get 25 upon limit extending to 0 e to the power 5x minus 1 upon 5x the whole square. So this is getting the ones as a value, so 25 into 1, so we get 25 is the correct answer of the second question. So the correct answer of the second question is 25. So we have to check and we have to get that the e powers values as same as the denominator and the expressions is minus 1, means we have to just do so and take it as e to the power x minus 1 upon x. We can just try to replicate this thing to the expressions. If we do so, then we can apply the values as 1, because we know that expressions values is 1. So I am waiting for 1 or 2 minutes, then I have to proceed to the next question. So I am proceed to the next question. So the next question is related to the C programming. So the question is like this, and this is a 2000 question. So we have to find it out the expressions value at the end of the expressions. We have to find it out the expression values as j, and then we have to getting a functions and also a static value, static variables count is present, and the main functions is also a there. So we have to find out the j at the end of the expression. So the function is there incr, which gets the in returns the integer type of value, and getting the some argument, one argument as integer, and stored the value, and the stored the value is I, storing the value as a variables I, and a static variables, uh, एंड एंड एक काउंट नाम का स्टैटिक वेरिएबल यहाँ पर है, उसका वैल्यू एस जीरो असाइन है, and the count values is increased by the values of the I, and then the functions returns the count value. Then a main functions is there. So main function, so once I and j is initialized with the main, and then a for loop is there, and the for loop calling the incr functions. So at the end of the expressions, we have to evaluate the values of the j. So at the beginning, so the we know that the functions is starting the main method. So the main is calling, so I and j values is being initialized. Okay, then the for loop is being counted. So for I is equal to 0, then I value is assigned to 0, and then incr of I means incr of 0 is called. Okay, so incr of 0 is when called, then is go to the this function, and for these functions int I is taking up the 0 value. For these functions I value is 0. Now count is equal to 0, so this is the static variable. Static variables is always initialized with 1 and incremented by the time. So count, for this count is equal to 0. Okay, so count value is 0 plus I. So count value is incremented. Count is equal to count का value. Count का value पहले value क्या था 0, and I का value 0. So count का value है 0, and 0 value is returned. So J value is being 0. So count 0. So 0 is being returned with 0. So J value will be 0. So first iterations J values will be 0. Okay. Then again I value is incremented as 1. So j is again calling incr of 1. So again incr of 1. So count value is now incremented with count previous is 0 and I 1. So count ka value is now 1. So now count is being returned. So j value is being now is getting 1. And in the third iterations I values will be 2, and checking the condition 2 is less than is equal to 4. Yes, the condition is true, so the functions will be called. So j is equal to incr of 2. So now count value is initialized, so not this line is executed yet. So count is equal to count previous, means count previous values is 1 plus I value is 2. So count value is 3, and 3 is being returned. So j value will be 3. Now for I, and I value is incremented now 3. So 3 is less than is equal to 4. Yes, it is always also true. So j value is calling the function incr of 3, and then count value is being incremented with count previous 3 plus now value is I3. So count value getting incremented by 6, and then 6 value is being returned with j. So j is taking the 6 value. So now I value is incremented with 4. So 4 is less than is equal to 4. Yes, this is also a true statement. So j is equal to incr of 4. So incr of 4 means count value will be incremented with count previous. So count previous value is 6. 6 plus 4 getting 10. So 10 count value is being getting 10, and is return count value. So count return is being assigned to j. So j value is being 10. Now the next iterations I value is incremented with 5. So 5 less than is equal to 4. No, this is the false statement. So it exits the loop, is exist the loop. For this is exist the loop and stored the j value as 10. So at the end of the expression, so the question is at the end of the expressions evaluation, what does the j value j value. So j value is being 10. So answer of this question is 10. So correct answer of this question is 10. So I am waiting for 2 to 3 minutes to take. If anyone having any doubt related to this question, then please ask. So for the gate examination, this type of expressions and the looping question is being asked. So we have to very much careful about this. So thanks for watching. We are now wrap up these sessions from the 2 days. We are again came live from tomorrow and solve two to three questions or five questions as many of are live. So then we are solving the question. So thanks for watching. If you need this type of content, please like, share, subscribe to my channel. Thanks. Bye. Happy day. And try to solve the gate questions as much as possible, as gate exam is being very much near. Bye. Keep learning, keep exploring.